Hey, you guys. All right, we're going to continue on with proportions. I will have to say that this is probably the most used lesson that I've continued to use throughout like my entire life. Like normally when we say you don't learn, like when are we ever going to use this? This is the time. This is the time where we're talking about proportions. So let's get into it. This is the section applications on proportions, and there's a couple ways you can use them. So our first example. All right, first example, you can use proportions to find missing measures. To find missing measures. So if I wanted to draw, let's see if I can draw a decent looking shape. And yes, I'm going to cheat using this thing. And so if I were to draw a triangle like this, and now I'm going to draw another triangle, but it's going to be a little bit smaller, but pretty much the same dimension. Okay, there we go. So these are two similar triangles, okay? And we'll have to use a little bit of symbols here. I'll call this triangle A, B, C, and this could be triangle D, E, F. And then I'm going to tell you that triangle ABC is similar, and that's what that symbol is right there, similar to triangle D, E, F. All right. Which means then, what if I were to give you um, some numbers here? Let's call this 5, and we'll call this 8. All right. So then for this one, actually, I think I did that wrong. I'll call this 5. Oh, I didn't want to go back that far. Jeez, oh, please. So we'll call this 5. We'll call this 8, and this one we will call X. And we'll call this 12. All right. And so because this only works because they're similar. All right. This only works because they're similar. And so what you would do is you would set up a proportion to solve this. You would say, and you would consider here's your first vocabulary word, you would consider their corresponding sides. Corresponding sides. When I think of corresponding sides, I really just think of sides that are matching, is one way I think of it. All right. And so, for example, we have corresponding sides. Let's line them up in a fraction, in two fractions, two ratios. And we could say that side AB corresponds to side DE, right? They're both on the left, okay? And then we could say that side AC corresponds to side DF because those are both the base of the triangle, right? The rest of it is just substitution. Okay, so I'm going to go ahead and place. I'm going to say side AB is 12, side DE is 5. Set that equal to side AC, which is X. This thing we don't know, and side DF, which is 8. Okay, and then the rest is history. We're going to cross multiply and divide. 12 times 8, and then on this side we'll have 5x. So that's going to be 96 equals 5x. Then you'll divide by 5 on both sides. You can answer like 19.2. 19.2, and these were all in feet. All right? And that's how long this side is. This side is 19.2 feet long. Okay. So once again, you can find missing angle measures by making a proportion. By making a proportion. Let's do another example of a way we can use proportions. Notice my artistic ability. I've drawn the most amazing thing that you'll ever see in your life, and you're welcome for that. Uh, so here's the sun, and notice the sun casts a shadow when it's shining on a building or a person, whatever. And some shadows are long, some shadows are big. Okay, but say you wanted to know how tall this building was, for example. I don't know what you're going to do on this building, but you need to know how tall it is. All right. Using proportions can tell you how tall this building is without you having to go to the top, take a tape measure, and jump off and see how long that was, because that'd be silly to do, right? So here's the things that you can measure. Even though you can't measure how tall the building is, you can measure how long its shadow is. right? Because that's on the ground. You can also measure how tall, you know how tall you are, and then you can measure how long your own shadow is. So these represent the things we know. This I could find, right? I could find this and this and this. Okay. So what we're going to do is, once again, we're still going to use the idea of the corresponding sides, corresponding once again. And so we're going to say this time that the x feet, that's the height, that corresponds to how tall I am, 6 feet. And I'm actually going to write it a different way. Uh-oh, be quiet. Be quiet, Bixby. And I'm actually going to write this a different way this time. I'm going to say that x feet corresponds to how tall I am. All right. And then the 45-foot shadow, 45-foot shadow corresponds to my shadow. So as long as everything matches up, we're going to be good to go, you guys. We're going to be good to go. All right. And so the same thing applies. You're going to cross multiply and divide. Now, this time I'm going to simplify first because I can. Hello. All right. I'm going to simplify first because hopefully you notice that this 6 and this 3, that becomes a 2 and that becomes a 1, right? And so now when I go ahead and cross multiply and divide, I'll get, 45 times 2 on one side, and I'll get just x times 1 on the other side. So that's going to be 90 feet equals x. And that makes sense that this side is 90 feet tall. So that's another way you can apply proportions. Now, very briefly, let's go over some vocabulary that you've learned so far. All right, so far you've learned that corresponding sides are matching sides. Okay, and then you've also learned that that similar figures, and so this is that symbol for this here's that symbol for similarity. Similar figures have the exact same shape, but not the same size, Okay, same shape, but not the same size. And that's what we noticed about this first one here. All right, notice this triangle is a little bit bigger than this other one, but they are the exact same shape. They're just not the same size. Okay, and so now let's look at another word called a scale factor. All right, called a scale factor. Scale factor. All right, and obviously factor being something you multiply by, right? Something you multiply by. And so, and if you think about this problem that we just did, you notice how this 45 feet, this shadow corresponds to this, it's related to the height of the building. Notice if you doubled that, if you multiplied it by 2, that you would find the height of the building. Notice also if you multiplied the feet over here by 2, you'd find the height of the person, right? So you could say that, in a sense, you could say 2 is a scale factor, because if you multiply both of these corresponding dimensions by 2, you'll find their other corresponding dimensions. So that works that way as well. All right, now a couple of things I want to prove to you, because they ask these difficult questions sometimes. Some things I observed, that the ratio of perimeters is equal to the ratio of corresponding sides. Now, remember when we say perimeters, we're talking about the sum of all the sides. Okay, that's the sum of all sides. Okay, and your corresponding sides, remember think of those as your matching sides, right? Okay. What was that? All right. So the ratio of perimeters, remember, a ratio is just a fraction, like A over B, is equal to the ratio of corresponding sides. So let's see. If we were to find the perimeter of A, if we wanted to find the perimeter of A, that would equal, let's see, there's 2 4s. Here, let's do the formula for perimeter real quick. That's 2L plus 2W, okay? And in this case, that means there's 2 of the 4s, one on this side and one on this side, and plus 2 of the 2s. There's one down here and one up here, okay? And that's going to equal, see, that's 8 plus 4, and that's going to equal 12. All right, that's this perimeter. And the other perimeter is going to be the same thing. That's going to be 2 of the 6s plus 2 of the 3s. And that's going to be 12 plus 6. That's going to be 18. All right. Now remember, they said the ratio of the perimeters. So if we're talking the perimeters, so and the sides is pretty obvious too. So if we're talking the sides, the ratio of the sides is 4 to 6. You know, it's also 2 to 3, and those fractions are the same anyway. If we're talking about the ratio of the perimeters, that's going to be, now notice we did A to B, so we're going to do A to B again. That's going to be 12 to 18. But if you think about it, what are both 12 and 18 divisible by? They're both divisible by 3, so that would give us 4 to 6. They're also both divisible by 6, and that would give us 2 to 3. So once again, notice we just proved it. The ratio of the perimeters is equal to the ratio of the sides. These two big statements are exactly the same. All right. Then they give us another statement. It says the ratio of the areas is the square of the ratio of the corresponding sides. All right. So let's try that. Let's try that. So if we were to take the ratio of the sides squared, sides. All right, and so the areas, well, obviously the area of the area of A is 4 times 2, which is 8. And the area, so that's area of A, and the area of B is 6 times 3, which is 18. And so the ratio of the areas is 8 over 18. And that's supposed to be equal to this 2/3 squared, right? So what is 2/3, all of that squared? Wasn't that 4 on top and 9 on the bottom? Are these two fractions equivalent? Are these two fractions equivalent? Another thing you can do that we haven't talked about, finding equivalent, checking equivalent fractions. If you want to check an equivalent fraction, just cross multiply. Just cross multiply. So if I were to multiply across here, I would get 72. And if I were to multiply across here, 18 times 4, 3, it's 2, 3, 4, 5, 7. That's also 72. So we know that this is equal to this. All right. So that's what they mean when they say the sides, the ratio of the sides. I'm sorry. Let's read it. The ratio of the areas is the square of the ratios of the sides. Right? And then for volume, the ratio of the volumes is the cube of the ratio of the corresponding sides. All right, the cube of it. So it just basically goes up from there. All right. Those are some examples of how to use proportions and all that. This checking proportions is very important. Just knowing that all you have to do is cross multiply and you can tell if something is proportional or not. So we'll get into the next lesson now after this.